Morning, and welcome to the CADclass podcast. I'm Josh,
I'm Jake.
and we're
We're back.
back.
We're finally back. Good
Oh,
Lord.
Jake. Whoa. We have locked ourselves in a room until, I don't know, until we suffer enough to get out of the room. How does that work, Jake?
Basically, yeah.
Yeah.
I've been telling my fiance, like, yeah, when are you coming to bed? I'm coming to bed when my eyes hurt.
Tomorrow. I'm coming to bed tomorrow.
It's usually tomorrow.
Which is always funny, right? Because tomorrow, in that sense, never gets here. Tomorrow. Yeah. Every day is tomorrow. Well, it's good to be back,
guys. We are that close.
We have a thing. We have made a couple of things. And we have shown off some of your things. I know we've shown you your.
No.
Whatever.
We are on schedule to publish today. Like literally, as soon as this part is done, we're gonna be jumping back on basically the final read over, and then publishing today. So, for you guys that don't know, as soon as we click publish, there is a randomized mystery amount of time until it's actually available on Amazon. For some reason, I don't know why, but it's not instantaneous. But
well, I partially know why. So they go through a review process, and they look through also the images. And I think some of it's actually manual. So they basically pay people to look through their books. They have a pretty decent quality control unit. It's not perfect, but it's pretty decent. So they'll look through all the pictures and all the images, and it takes however long it takes. And there also might be some back and forth. So they may come to us and say, "There's an image on page 209 that's too small."
They may also come back and go, "Hey, this sucks. This is terrible.
We're never publishing your books again. This is awful." We hope.
I'm like, "Can I please publish it?" And they go, "No, it sucks."
I know. We really hope that this time around, though, we're trying to roll over all the reviews that came in from edition 1 so that we don't lose a lot of momentum on that and push all of them towards version 2. But if for some reason that doesn't happen, we're going to rely on you all, our audience, to please buy and review the book so that
if you can,
so that we can make our way back up in the rankings. Because I think by the end of it, I think we're either number 1 or number 2, right? We go back and forth with the Make Magazine book for number 1 or number 2.
Really quick, just to answer Joe Street. Yes, the PDF will be available instantaneously.
Yes.
We always want to make that available. All the new projects, all the new files, all the extra bits and bobs that we've added on will be completely available on the Google Drive as soon as we click publish.
For free or for a $500 donation.
Oh, yeah, we've capped it now. That's now the minimum.
Yeah. Just kidding. I think the lowest donation is 50 cents, something like that.
Yeah, people do 50 cents. I
like
saw someone do like 1 cent, and I'm like,
no, you didn't see it. Nope, that's a lie. No,
nope.
I've tried. No, because I've poked around. I'm like, what actually is the minimum? I'm not even 100% sure how people get 50 cents in there. I've tried it, and it didn't work for me for some reason. So I don't know.
It's fine. We appreciate.
They know more about how to do it than us. But anyways, really quickly, good morning to Joe Street, Cadence, Cornelia, Johnny. You're the fan. I already said Joe Street. You almost got you twice because you got in here so early, Joe Street. But
it is twice. Everyone only gets one.
It is good to be back. I know our YouTube content has been non-existent for a little while. We somehow, I don't know how we do this, Jake. Somehow we still underestimate how much time it's going to take to make all these changes. But we can assure you it's going to be way.
We're coming back in a bit. We had to kind of put our heads in the sand for a little bit.
Yeah.
Then come up and breathe for air. But yeah, all the fun, cool stuff that we love to do that doesn't resort to just being in a dark office is coming back. Coming back with a passion. So excited for that.
Yes.
So today we're going to be going over, good Lord, 3 weeks of I made a thing.
I made a
which
stuff.
I've just been I made a thing stuff.
I made a stuff.
And God, the amount of stuff that I've seen, I'm just like, I want to talk about that so badly. But we're also going to play a little game show today called X with Y. That we did not steal from the MKBHD podcast, where you go in the world of 3D printing or CAD or making, whatever you want. Thing X would be perfect if it had Y. And so Josh and I are going to rally back and forth. I actually feel I have a hunch that we probably won't have any crossover. I think we'll be coming up with totally different things.
I think you're right. I
Yeah,
think you're
cool. But I think we should dive into Discord.
Let's
Sure.
check out the things people made. The thing makers.
That's a good one. I like that. The
You like
thing
the
makers.
thing makers?
So start off
This
from the bottom.
Yeah, right on the very bottom here. I wanna just mention
So rad.
hilarious that it's the marble car. This painting with Hue Forge, I'm still fascinated with.
Mhm.
We talked about it a little bit on the previous podcast, but this is I can see this is the bamboo, with the couple frame in there. This is the bamboo
Mhm.
3D printer with filament management. Once again, unbelievable how good these printers are.
Yeah.
I really dig in the Ender 3 V3 as well. So shout out to our Creality ecosystem where we've done most of our building. That Ender 3 V3 is still
Mhm.
really good, but man,
Those
hard to beat
bamboos are
that.
crazy.
And look at this. I mean, this is you look at it and you think it's a picture. And
Yeah,
no,
no,
this
especially
is
in the helmet, all the detail is just ridiculous. You
it's
can get out of
amazing.
it.
It's amazing.
God, that's ridiculous.
We've got
So
some
good.
comments. We got some feedback. We have actually had this feedback a couple times. So Marion and Joester are like, I think you should remove the 360. So I want to really quickly just address why we're actually going to keep 360 in the
Oh, yeah.
name this year. So we decided basically because so many people still know Autodesk Fusion 360, actually Autodesk Fusion as Fusion 360. We decided to keep the 360, and that is for search engine purposes. So a
It's
lot of
it's
people still
a
go
it's a
on,
transition period.
just like
I mean,
people,
like, the
right?
subreddit is still called Fusion 360, for God's
Exactly.
sake. And
So
there's
just like people still search for Twitter and not X, that will eventually change completely. If you were
yeah.
mentioning something that had it in the name, right, you'd probably lose some of that traffic. So we're going to do both, mastering Autodesk Fusion, but we're also going to add the 360. And hopefully, the
By
idea is that
edition 3, it'll be the
edition 3 it'll
correct
probably
name,
be
which is
gone.
Mastering Autodesk Fusion.
Yeah. So
But for
that's the
now,
whole reason. We're keeping it, sticking to it. But good points. All right, back into the
yeah.
animated thing.
Oh, gosh. God, Josh, why can't you just keep me on this one page? We've got, I believe Johnny, he's from the Rabbit group
Yeah.
with a little 1 pound. I mean, oh gosh, it's a tombstone style. It's a horizontal cutter.
Mm-hmm.
These things
Mm-hmm.
are mean. These things are so mean. I'm sure you can see on the reflection the plexiglass on top. These things are devilish. Like I've seen people play around with them and just shred up their ankles accidentally. Absolutely ridiculous. And then Ty Snyder as well, working on a little robot dog. I love these. They're so adorable.
So fun
The thing
story.
about the
So
what was
fun
that?
story about so I have a fun story
Oh god.
about this. So we were at the Capitol Air Show with Sac City College,
Mhm,
watching fighter jets do absolutely unreal stuff, right?
mhm.
And Richard from Sac City College brought out our robot dog.
Oh.
Nobody watched the air show. There's these little kids. The especially interesting thing is that the younger the kid, the more interested, for the most part, the more interested in this dog they were. They all pet it. They all walked up to
Yeah.
it, pet this robot dog, and the little kids were obsessed.
Oh, yeah.
Everybody was obsessed,
Because
but
of course you
the
would be.
littler ones, the middle age and like high school kids looked at it like whatever. I don't care. But it just reminded me that as technology changes and we get older, uh, the younger generation is just completely integrated. This is normal, right? Robot dogs in 20 years for these kids will be like, oh yeah, well, that's been completely
Yeah.
normal our whole lives. So,
Yeah.
anyways, back to Ty. Ty was part of our Roseville Rising cohort, and he's been working on this
Gotcha.
robot. He's been working on
Oh,
this
there he is.
robot dog for a long time.
Yeah, this thing is beautiful.
Yeah.
This thing is so lovely. I've convinced my fiance if I said, "Oh, instead of getting a real dog, can we just get a robot? Can I just make a robot dog?" The stipulation was you can either have a real dog or you can have a robot dog and a real cat. And she goes, "Oh, I'll take
Mhm.
the cat and the robot." I was like, like that, I can totally live with that. That's fine. Um, Going to
Wow.
Logan Branson. I think he's a relatively new person.
Mhm.
I've been working on this modular DDU system for sim racing. Not sure what that means. This is the latest I've been working on with a prototype. Nice little render, not too shabby, but the final setup,
Yeah,
that's nice.
that's really rad.
That's really cool.
Yep.
I'm not quite sure what DDU is. I'm sure someone will tell me, but that is really cool.
It just opens
So
up this world. I mean, I know we're preaching to the choir here, but 3D printing, 3D modeling, learning CAD, it just opens up this world of customization. It's
Mhm.
everything is customizable. No
Yeah,
reason not
3D
to.
printing is always more fun in tandem with with another hobby. I think just 3D printing on its own, unless you are an established maker and you know how to make cool stuff, I think it amplifies, for lack of a better word, other hobbies. If you're a musician, a woodworker, if you're into drones, if you're into photography, if you're into really seriously anything, it just allows you to. Again, we're preaching to the choir. You guys know this. It just makes it so much more fun. Love that. Um, Daria making some decorations for a baby
This is
gender
amazing.
reveal.
This is
That's
amazing.
pretty awesome. I mean, I
Those
don't know
look
the scale.
like
That is a
spray
big print.
painted lac tables. I'm not sure if they are, but you know the lac table, the IKEA
No.
lac table?
Yeah, yeah,
Can you
yeah.
t
I know what you're
I
talking about.
that's what it looks like to me with
No.
what do you mean
No,
no?
because these are 3D miter joints on all the corners.
Oh, you're right. So
Yeah.
those are customized. That's what's 3D. I was trying to figure out what part of this is 3D printed. Do you think it's the frames
I think the letters maybe,
and the letters?
but the frame definitely. Yeah. Oh yeah, yeah, yeah.
Yeah, that's cool.
But
That's
yeah,
very
that's
cool.
rad. We're going through this pretty quick. Derry, he actually gave me a huge amount of help. I know I've shouted him out a ton, but he gave literally a ridiculous amount of help making the drone project. And if you guys can see this, but replacing the silicon mold project with a prototype drone. Thank you so much, Derry. Huge amount of help, huge amount of research, huge amount of expertise. Casual expertise is my favorite. Where they go, oh yeah, just do this, and this. Okay, great. So this is very similar to the final project. Super fun. I really want to make this in real life. But I think we'll probably be blowing it up just that little bit, so we're kind of hitting the upper echelon of the weight limit, just so we can make a pretty kick-ass custom filming drone rig. Blah, blah, blah. But yeah, absolutely fantastic. Thank you so much, Derry, as
And I'm planning
always.
on making one of those drones, and also, I don't know if I think we may have mentioned this before, but, we're planning on chatting with PCBWay to get a carbon
Mhm.
fiber version of this made as well. So stay
'Cause
tuned
why
for
not?
some videos about, coming up with an idea, prototyping it, and actually getting a real project made.
Mhm. Super awesome. Um, a little bit of a mess with the geocache hide, and I can tell immediately. One of the reasons that is I think they may have the E millimeters turned on. Perhaps that's why it's getting a little bit of under extrusion. But just a reminder, if you do want to 3D print the little geocache project, you don't need any support material. Threads are usually or the threading are usually 60 degrees for a metric thread, and so when you tip it on its side, that is a 30-degree overhang, which is totally fine to 3D print. So you really never need to add supports to vertical threads on a 3D printer. But yeah, I think just a couple settings you need to tweak for this, MKL. But yeah, when you do print it out, make a geocache. It is so much fun. Oh, same person making a replacement canoe paddle for my daughter's
I just love that
Barbie.
so much.
That's so rad. That is so fun. I love that. We had to replace one of our geocaches with a fake stone. Is that whole thing a fake stone, or is it just the bottom cat? Oh my
Just the
god,
yeah.
that's pretty sweet. I like that. Oh, Connie, amazing as always. Um, Working on a fun little project. Oh, this is Ethan for the Maker Faire Orange County. This is a puck that will take some magnets and hold 1-inch PVC tubing, so you can make some signage. Again, super quick and easy. Can you imagine how much time it would take to actually manufacture this way in any other format than 3D printing and have it still be dimensionally accurate? Like, can you imagine making this out of wood and having to make
You just
dozens and dozens and dozens of them, or out of
yes, I can
metal?
imagine it, and I want to immediately stop imagining it.
Yeah.
That's
Oh
it's
god,
just yeah, nope,
that'd be
nope.
horrendous. Joshi coming back with another BattleBot. so excited about.
Yeah,
Dude, I
yeah.
want to see this rip. We've actually included a bunch of pictures of his original BattleBot, which I'm totally forgetting the name, in the book. We do have some collages of some of our favorite projects that you guys have made, and so we'd love to see this. And we're showing off our favorite projects. But yeah, Josh, what a fantastic time. I'd love seeing
So
all that.
and we added a bunch of these, maybe not those specific ones, but we added a bunch of these to version 2 of the book. So
Mhm.
we went in and
Code
picked
breaking.
some projects that looked interesting, and we're gonna continue to do this hopefully for the foreseeable future in the program. So share your
Mhm.
stuff. It might make it into
Yeah,
the book.
love to see it.
Yeah.
All right, Josh, I want to do a little game, the X with Y.
Let's do it.
I just kind of like this because it was really kind of making me think of all the different types of not just 3D printing, but all the different software and tools that we use, and all the different things of how they suck for usually just one big reason, and they usually often completely fixable, which always kind of drives me nuts. Like I understand having the cheaper end of 3D printers having flaws. Yeah, I get it. No surprise there. But on like big machines or even types of machines having this one fatal flaw that is really annoying that everyone recognizes, that just bugs me for so many different reasons. So Josh and I are going to rally back and forth on X with Y. Uh, Absolutely, guys. Put if some are coming to your mind, put it in the comment section, and we will give you guys a bit of a shout out and see if you guys can come up with any better ones than us. Um, some of them are going to be totally minor, and some of them are going to be very radically different. Yeah, this is terrible. Scrap it and change it by this very fundamental feature. But Josh, I want you to start. Give me one X with the Y.
Oh, man. See, I didn't put much thought into this. I mean, I have one thing that I fixed a while back, and bicycle kickstands not having an
Mm.
additional little flip pedal for your foot to easily snag, right? Just like a little tiny flip out pedal. Doesn't have to be a straight kickstand. I like to be able to roll up and just flick the kickstand out. Why don't they have a little flag? Just a little bit
Mhm.
meant to snag your foot just a little. That's it. Doesn't have to come way out and interfere with the pedal. I don't know. Should have it.
Do you have a 3D printing X with Y?
3D printing X with Y. You go first on the 3D print. Let me think about it for a
All right,
second. I think I do have some, but I have to dig into the trenches of my brain to find them.
that's fine. My first one, which is a fairly fundamental thing. Do you remember belt printers?
Mhm.
Do you remember how awesome and how excited we all were for the idea of like a new breed of 3D printers, and then they just turned out to be crappy?
Yeah.
Like, I just remember how like disappointed we all were with like how how bad they looked, and the whole reason that they looked like that is because with a belt printer, you were able to print with an infinite z-axis by just moving the belt, but it meant that you have to print at a 45-degree angle every single time. So the entire gantry was up at the side. And so to get that first layer was essentially just a line. And if you messed up on that one line, the rest of your print would just fail. It would just completely fail. And the amount of projects that I saw that would actually use this infinite z-axis was like cosplay swords, and that's it. That's basically all I saw. Like across the entire community, people were making like, oh god, what was it? They were making like one-to-one replica of like Legend of Zelda swords, and that's it. And I'm like, oh, that's yeah. Like, there's not too many things that are like less than 10 inches wide and very long that I absolutely need to be in one piece. It's like the amount of things that I saw like that were just so minimal, comma, the amount of people that I saw that were then just using it as a batch printer, where they made, for example, just a little benchy, it would move out of the way. Make another benchy, move out of the way. And then they just put a big bin underneath the belt printer, and then it would just fall off. And so you could just set infinite amount of these going all the time, and it would just be the perfect example of mass manufacturing. And so if I wanted to improve belt printers, instead of a 45 degree, I would just set it up as a normal 90-degree 3D printer. And that's it. Like it is literally as simple as that. It can even be the exact same like standard 10-inch, 10-inch, 10-inch build volume, but then just a belt. So as soon as it's done printing, it moves it off. I have seen so many people that have mounted these belt printers onto their walls vertically, and then they are just constantly printing normal standard parts into a bin, and then it just keeps on going. And they are basically saying, I would have had to edit a bunch of different software or make a custom rig or wait for the parts to fully cool down so the head could knock it off. All these like extra annoying custom automation things that's just a nightmare to fix because it's all custom. And they were just saying, well, if I just had this belt printer, it would be perfect. And I've seen basically no one try to modify it to just be a normal 3D, to be a normal 90-degree belt printer. But I've wanted that for so long. So long. What do you comment on that?
Um, I have some. The belt printer to me represents, for the most part, the opposite of what 3D printing is useful for. So 3D printing, especially on a home scale, is and maybe even a small business scale, to me, is fantastic for prototyping. It's okay for small batch manufacturing, depending on what that product is, and it's pretty bad for large part building. So the first
But it
part of what
is
you said,
when you have the human element. If the machine is doing automation 24/7, great. Then I think it's totally an option for large scale manufacturing. Or for large quantity
yeah,
manufacturing.
yeah, I
Depending on
mean,
the product, obviously.
then you have to put in these fail safes where it's not a technology that's really tested to be 24/7, and so the fact that you're testing, like, if you could, if it existed in a perfect world where you knew that it was gonna succeed the entire time, and or you had fail safes so that if it does fail, it just stops and kind of alerts you to it, I can see the use case for it. But part of the reason I look at the traditional printing and I go, it's kind of fine, is, one, those belt printers are really slow compared to the newer, even the bed
Well,
slingers coming out. And two, you almost
but in
wanna.
this scenario, you could just have a Core XY and just have it be as fast as you want, and the Z-axis isn't moving at all.
So it could be okay. It could be okay. But again, it's how much large scale manufacturing do you do with a 3D printer before you say, you know what, we've got enough, we're making enough of these parts that we should just injection mold them. It's time to make a mold. It's time to move on to the next technology. There's an interplay between the other technologies. I'm not saying there's no room for belt 3D printers, and I'm not saying there's no room for a faster one. I just think I'd probably, if it were me, I'd just take 5 Bamboo Minis printing small parts over one belt printer because it's about the same price. I think they're more than
But then you
$1,000.
have to manually move the bed or remove the bed every single time a batch is done. Every
That's
single time.
fine. 5 of those will outcompete it by orders of magnitude, like 5x productivity. So that's fine. Once every day you pop in, you pop the stuff off. I see the point. It's not, to me, 3D printing is not a technology that is designed to be scaled in that way.
I
It's
disagree. I think there are certain parts that are built on customization where people need a custom file to be changed, where, you know, plastic injection molding just doesn't work for that. And also custom colors, custom materials. Like all of our clients that say, "Oh, I need this one part to be printed, or this one product that has dozens of customizations, tiny, tiny alterations, and also each of those needs to be printed its own custom color." That's a nightmare to do for plastic injection molding,
definitely.
and they
Yeah.
need thousands and thousands and thousands of them per
Yep.
year.
For the right use case, I think it's okay, right? So for the
Mhm.
right use case, I think it works. I do think there are a couple use cases. I'm not sure. Like, part of the reason that we transitioned away from 3D printing as a service is because those use cases are few and far between. It's really hard to find somebody that wants to print enough of those to make it worth your time. But really quickly, we do actually have a question in the thread,
Oh,
and I want to switch for just a second here. So
go
we've
ahead.
got Marion. Let's see about threading. 3D printed M20 bolt plus nut, no tolerance, are very far from fitting, while a 3D printed nut, also no tolerant, fits perfectly an existing M20 metal bolt from the hardware store. Why? And then he said, if I
Ooh.
want M20, should both the cylinder of the bolt and the hole in the nut be 20 millimeters, I think if it's slightly off, Fusion still picks M20, which is strange if the hole and cylinder are not exactly 20 millimeters.
So Fusion. So let me just go to the first one. 3D printed bolt and nut with no tolerance do not fit. That's just kind of standard law. As 3D printers work, they are laying down a molten plastic, which is then oozing out until you always have parts being ever so slightly larger than the CAD model allows. That's how you get good layer adhesion. When you say, okay, I'm only having the nuts be 3D printed and the metal part is now not 3D printed, you're essentially taking that expansion, that oozing, and dividing it by 2 because literally only half of them are actually fitting, have actually expanded. The other thing is that the threaded rod is actually slightly less material of the thread. It's actually cut more than the 3D printed file. Because usually threaded rods need to be really, really quick to spin on, like a quarter 20 thread with a quarter 20 nut needs to spin really, really quickly because they're not really worried about really tight tolerances, where the CAD file or the Fusion threading tool will make a perfect thread, a perfect exact thread with no clearance and no tolerance. So that's usually why it's fitting in place. For the second question, if I want an M20, should both the cylinder and the bolt be 20 millimeters? Yeah, you can do. If you say, oh, I have a 20 millimeter diameter cylinder, and you add a thread to it, it will automatically set it to an M20. If you have it set at 20.5 millimeters, it will just assume, oh, this is close enough to 20. So it will just automatically correct that. But it won't set in any tolerance or any clearance whatsoever. So you then need to go in, and it's usually easier to do this on the male to actually offset all 4 faces of that thread. But
Which
if you
we
switched, we do it in the new metric bolt project. In the first edition, we told you to do it on the female thread. I don't know why, but it's so much easier to do it on a male thread because you can see all the outside faces instead of having to look on the inside of a hole. I don't know why we did that. Sorry about that. Again, we've done so many corrections, and I'm like, why did I do that? I don't understand why. Anyway, but on some threads in Fusion, it will have the word designation, which is a fancy word for a clearance, a fit, but an actual, gosh, how can I say this? Instead of saying, oh, it's off by like 0.1 millimeters, it's actually like a class where it's like a recognized amount of tightness or stiffness or looseness, where it's actually like a measurable amount that you can find. So, oh, aerospace, things need to be perfect, absolutely tight as can be, so it screws on great, or something for construction where they just need to go really fast, so it can be loose. Anyway, there you go.
Nice, yeah. And by the way, just a reminder for everybody else, we started this podcast so that you could ask questions like that. So thanks for popping that question in there, Marian, and feel free to pop your questions in as well. So we can always go back and forth between philosophizing and answering your actual questions. So good stuff.
Yeah. Next, 3D printed houses would be better if they were igloos. Let me expand on this. Okay. 3D printed houses have been around for 10 years, and I've never seen one. They don't work. Like, it sounds rad and it looks awesome for them to be made. They don't work. They're usually made by mixing concrete with an incredibly fast reacting agent. So you can basically extrude a concrete slurry and it cures incredibly quickly. Some of them have built-in fibers, so it adds a bit more strength to it, layers down in really thick layers. It looks awesome. There's a few houses in, I think, New Mexico that a company made.
Texas
They
as
look,
well.
in Texas. They look rad. They look so cool.
They're architectural marvels, is what they are.
Yes, they're also artworks. They are
They
pieces
are.
of art. They're huge, and you go inside, and I've seen videos of them like touring it as a model, and they are rad. And then you start to think of like, oh, I just want to put up a picture. Well, I can't just use hammer and nail. I need to get out my concrete saw or my drill bit, my masonry drill bits. Where are my masonry drill bits? I want to put up a picture. Oh, I want to mount a TV uh in my new room, and I don't want any of my wires to show, so I need to thread my wires through the wall. It's, oh, too bad. That sucks. I think. Oh, so different tangent. So full size houses, I think they suck. They don't work very well. Okay, but transitioning in the world of hiking, I guess. They go by a bunch of different names in a bunch of different countries. The one example that I'll give is in the Highlands of Scotland. Huge, huge areas where very, very beautiful. Lots of people love to do long, like days long hiking trips where nobody lives there. It's basically as remote as you can get in a fairly small country, and beautiful, beautiful, beautiful. And along the ways, just at random locations, seemingly, there'll be these houses, usually made of wood, and it is a good grace house. I think that's sometimes what they're called, where they have food supplies, wood, stove, water, sleeping bags, and people can go there when they're like, I've ran out of food, I've ran out of supplies, and they're in a scenario where, yeah, they might die. It's in the middle of nowhere, and it is a safe haven. And the idea is you can go in there, you don't need to spend any money. They're just naturally put there. And the idea is, oh, the next time you go hiking, you bring a surplus and you then drop off food that you don't need to these houses for the next person. It's all goodwill. It's kind of a beautiful idea. But these houses, because they're usually made out of wood and it is in a very rainy country like Scotland, they rot and they are destroyed. And so they're usually just safety houses. So my idea with 3D printed is that, well, you don't need a whole masonry team. You could just have essentially on a truck bed a CNC arm that just makes these safety structures, essentially an igloo, and then drives off to the next location where it doesn't need all of this. Oh, how do I put in my TV? How do I hang up a picture frame? You don't need it. It just needs to be a safety structure that needs to last in a relatively tough environment. And that's where I think 3D printing houses would work very well. Josh.
I agree. And I also think that one of the main issues, because you're thinking about like a yurt, or you said
Yes.
igloo
Yes. Thank you.
originally, which was that's kind of a fun way to think about it as well. Is yeah, it changes the way you have to think about constructing living spaces, is what it really does. Because especially here in the States, and Dan's like, dude, I live in a concrete and brick house. Um, and you're right, like a lot of the houses throughout the
Mhm.
centuries were obviously built out of these materials, and
Mhm.
we understood that it was going to take some time to figure out how to kind of build all the structures inside of it, and that's what we did.
Mhm.
But then we tried to turn to the mass manufacturing side of things, and so what we've basically done in the United States is we've created an entire industry around how to build inner guts of homes based on traditional building structures. And to go outside of
Mhm.
that traditional building structure is to introduce a world of hurt, exactly as you mentioned.
Mhm.
But I actually
And
completely agree with you.
the 3D printing houses, the concrete, are very, very different to a normal brick house.
Correct. And
I would say.
specifically
Those are
because
built to have plumbing and electricity built into the sides.
that's right.
3D printed houses do not.
Yeah, and
It
the way
is.
they lay down the layer lines and the way they actually come around corners makes it
Mhm.
really tough. Like if you're an interior person and you're trying to hide some of these corners, and maybe the answer is don't hide the corners. Maybe the corners become part of the structure that you have inside,
Mhm.
right? That's kind of interesting too. I think you're right. I think for the cabin, the it doesn't even have to be totally off grid, but the somewhat
Yeah.
less standard, I'm going to have a family inside of this structure. It works
Mhm.
really well. Otherwise, I'm actually a big fan of what we've been doing here at Community Shop Class locally, which is just metal framed structures that are CNC
Mhm.
fabricated out of sheet steel that's been bent. and strengthened in corners and kind of all has those rigids, and you can hang things up, and they're all built to be kind of ready to rock. But I totally agree with you. 3D printed houses, not that viable at scale, but 3D printed
It's
yurts
awesome.
and
It's an
camping
awesome idea.
structures, I think it's gonna lead to some amazing architecture. And I've already
Mhm.
seen a couple of them, and they're just beautiful to look at.
Yeah.
And I
Even
it's
the areas of the houses where I guess you would call it over extrusion, where it's like builds up pressure and then it oozes out. On the outside, it looks amazing. It looks so cool to have these random dripping bulges of concrete that almost looks like honey. It's beautiful. It's really amazing. I would love to go to one, but I just yeah. And also we see for like 5 years in a row all of these news headlines the first 3D printed house. It's like I saw this headline a week ago, dude. It's like
Yeah, I mean,
it's just bizarre for some
these are where
reason.
people's brains go, I think, that don't know that much about 3D printing, right? It's like
Yeah,
this technology that's magical and could do anything. Can you 3D print
yeah,
money? I've had this question before,
yeah,
and it's like, well, I mean, how deep do you wanna go? What
yeah.
is money? And yeah, you could 3D print something that looks like a piece of money, but
I've 3D
anyway.
printed a bit of plastic that goes on my keychain that's the size of a quarter, so I can put it in the shopping trolleys at Aldi. I mean, that's did I 3D print money? Kinda, kinda.
That is funny. That is really funny.
All right. Let's go on. Yeah, resin 3D printers with built-in ducting.
Hmm.
3D printers, they usually print pretty nasty, uh, noxious fumes that most people don't know how bad they are for you. And for some reason, every single time that you see someone who does know just how dangerous these gases are for you, they usually build this kind of superstructure enclosure. Whether it is, uh, I've seen people where they do it in kind of like a gardening hutch, or whether it is an actual like rigid structure, like a bit of furniture that has doors, and they usually have nice big duct fans that go to some ductwork, and it kind of puts all the gases outside. That is great. And the entire time that I look at these, I'm like, these take up. They're most resin printers. They're not much bigger than a normal 3D printer, than an FDM printer, and yet the superstructures around them are gigantic. They're huge because you need all this extra room to fit your hand to take the lid. And I'm like, why do we have these UV resistant plastic shells that go over the outside that don't have like any latching sealing like seals onto them with built-in fans that have like a nice ducting where it could just go to the outside? I'm like, what? Because every single resin printer that I've seen, the shell just lays on top of the tech on the tech frame on the bottom. I'm like, at least put a gasket on it, God's sake. Like I've had to design my own fan duct system that sucks air through the frame and it raises it off, and it's all this 3D printed shrouding that goes all the way around it, and that kind of works. But I'm like, is it like if I'm wrong, I will happily admit that I'm wrong, but it seems silly to put a superstructure over an existing structure. Like, am I crazy?
Nope.
I I don't know.
I mean, maybe,
It's my
maybe we just I don't understand the manufacturing behind resin printers all that well, so I I don't know.
but like the tenting that goes over it that I see advertised as like the hutch is tiny. It is so thin compared to the thick plastic walls that they do use on resin printers. I'm like, just have a hole on the back. Just have a hole on the back, and then just some clamps and like a rubber seal. Whatever. Whatever.
I have a slight, uh, kind of like an addition to that, I would
Go
say
on.
somewhat,
Go on.
and this is a broad why don't X, Y? So for years, the common way to connect things, when you think about putting two things together, especially two things even that need to be removed, like if you look at your computer, one of the things that Apple did in the early versions is they made a magnetic charger that just stuck on the side of it. And then if you hit it, it kind of knocked that thing off.
The
Uh,
MagSafe, yeah.
why don't we apply? the idea of magnetized connecting points to basically everything, right? So I've got a
I've
board game
seen
in the
that
bottom of my
for
board game.
woodworking shops. I
I've
wanted to
seen it
make
for
those so bad.
especially the ducting in woodworking shops where you have
Mhm.
movable hoses that need to move between points. Click it off one, click it on
Yep.
another, done, right?
Yeah.
Saves time,
And
saves
it should be
effort,
standardized as
super
well.
clean, should be standardized, doesn't have any hardware that gets gummed up because it's magnets and you can hide those magnets inside of
Mhm.
housing, right? And especially with 3D printing, now you can 3D print them in a way that you can
Mhm.
embed the magnets right inside of that 3D print. You never see the things, and then they just kind of clip on to other things. So when we need to attach things, why is it that we don't think more about attaching them with magnets?
Yeah. I
Cheap
I don't know
magnets,
why.
inexpensive. You can buy them in bulk, and you can basically use them for all kinds of things. So
Yeah. I love that. I got another one. This is more just like an annoyance, but I think standard 3D printer, you can put any brand name or any category you want. A standard 3D printer with a hardened steel nozzle. Do you know how inexpensive it is, or the price difference to go from a brass nozzle that they ship in the hot end and a spare brass nozzle versus just putting in a hardened steel nozzle? It's like a couple of bucks. It's not much. So why are we still messing around with brass nozzles? They wear down very, very quickly. They get all bunged up when you try and take them off sometimes, and you don't have the exact socket size. They like why aren't we just having like hardened steel nozzle as like the standard? You can print all types of these abrasives, funky material, and normal materials at the same time. It heats up more efficiently because it has a higher alpha rating than brass. It is just better through and through and through, and it costs a little bit more. This would be a different conversation if someone said, "Yeah, why don't you just put ruby nozzle or diamond nozzle?" It's like, no, the hardened steel nozzle is not that much more expensive. It is 100% worth it, and it should be standard on all 3D printers. I'm Jake Suggs and I approve this message. Why isn't that a thing? It's just silly.
I don't know, actually.
Like there's no way. There's no like even a really, really cheapy one. I'm not talking about like one that's been perfectly annealed, like to be the exact amazing, most perfect steel in the world. I'm just talking about like a steel nozzle. That would even like the one that hasn't been hardened, that will work so much better than soft brass. I don't know. I don't know why that isn't a thing.
I don't know. I
Um,
don't know. You got me wondering actually why they chose brass in the first place. I don't even actually know the answer to that.
I believe the origins of the original brass nozzle, I think it just I don't know for certain, but I know that it came down to just one guy. I don't even think it was a business because a lot of people go, "Why is it point 0.4 and not point 0.5?" And I think the answer is the guy that and I don't know for certain the guy that made the first nozzle, he just happened to have a point 0.4 nozzle. He didn't have or a point 0.4 drill bit. He didn't have a point 0.5, and so he just went, "Okay." And now the entire industry is it's gone with point 0.4. And I'm like, doesn't point 0.5, doesn't that just sound like a little bit better? Wouldn't that be a more common drill bit?
It'd also be easier
Absolutely
to
it is.
it would also be easier to design around because you could then
Yes.
design in half mil instead of
Yes.
point 0.4 mil.
Yep.
Hmm. Hmm. Hmm.
Yeah. So I think that person just had brass and had a point 0.4 millimeter nozzle and machined it, and then everyone went, "Oh, that works. Could you make it really inexpensively and en masse?" Yeah, great. We'll just go with that for the next 20 years. Insane. Okay. Um, this is one that I have that I'm almost positive I didn't invent, but it's something that I have wanted to see happen in the world of 3D printing to get a huge amount of speed increase with basically not that much extra hardware, not that much extra settings. But I've never seen it, but I kind of want to. And that is having a 3D printer that has two different nozzles, which is not uncommon. One is a zero point 0.4 millimeter, and one is a 0.8 millimeter nozzle, so that you can print the outer with a 0.4, so it's nice and clean, and the inside stuff with a large diameter nozzle. So for larger prints, you can print with a higher volumetric rate. And so you can print even faster with basically the same amount of time.
So one thought is there's already a printer that will do it. Do you know which one?
I know. I can't remember what it is, but I know what you're talking about. And my addition to this is that I don't know how to put this. I would like this to be an invention in slicers where you can have multiple thicknesses of layers inside a print. So currently, right now, there's a setting called adaptive layers where the software will analyze the curvature of your model, and anywhere that it's like really flat walls, it will have a really large layer, and anywhere where it's got kind of more slanting curvature, it will print with a really small layer height. So then it's kind of got the best of both worlds. It never works. It always looks like crap, but nice idea. What I'm thinking is that on the outside, let's say you have really, really high quality 0.12 millimeters layers on the outside. Great. But obviously that would take a million years. You do that with a 0.4 millimeter nozzle, it just does the outside. Then comes in a large diameter nozzle, and that can double it. So it does 0.24 layer height. So you're getting the added benefit of a really clean, tight, super duper high quality, super thin layer height on the outside, and then a larger nozzle with a huge flow rate that can essentially just do effectively two layers at the exact same time to fill in the gaps. I want that so badly. So badly.
So the answer is the Prusa XL with tool changer.
But that can't do multiple depths of heights at the same time.
Because of the slicing software?
Right? I'm imagining this as a slicing software invention.
Yes, but the Prusa will do any toolhead you want, and also it can do different materials as the infill, right? And so this is where I think this idea, and I'm still trying to figure out use cases in my head. We now have 12 Prusa XLs at my college, and half of them are set up, and I've started to play around and print with them. But I'm still trying to figure out like exactly what are the use cases, kind of like print in place was invented because 3D printing can do it. It wasn't something that people thought about really, at least I don't think it was prior to 3D printing. You can now embed mechanistic movement inside of things because of the way 3D printing works, right? And so I'm wondering what are going to be the future inventions because you can print with multiple layers, multiple nozzles, multiple materials, right?
I kind of want to see that foam PLA being used to fill in gaps on the inside.
Oh, that's funny. And then, so I do think you'll start to see some Prusa. I think their slicer, because we had to use the Prusa slicer for the Prusa XL. Maybe there are other slicers that will do it, but because it's so proprietary and it has that tool head changer, it's pretty unique to the Prusa. So I'm guessing you'll see I'm not sure if you'll see exactly what you're talking about inside that ecosystem, but I bet you'll see some similar advancements with the Prusa slicer.
Yeah, I've been wanting that for so long.
It's a really cool idea, by the way. I like that a lot.
Thank you very much. It's in my mind, I'm like, if you have double the height and then double the diameter, like you're effectively printing 4 times faster on the inside than the really clean outside, and you can, yeah. Anyway.
I mean, you could really push that too, right? Like, yeah, exactly. Like
you could go instead. You could go the most perfect quality on the outside, and then like a 1.2 millimeter nozzle. It's 9 times as faster on the inside.
Yeah. And actually, it's interesting because you're thinking about speed, but you're thinking about speed in terms of volume of material, which usually when people think about speed, I think they look at the tool head speed, and they go, "Oh, it's traveling at 500." But what you're proposing is not at all an increase in that speed, but an increase in the volume that it lays down. So that's really cool.
Thanks very much. This is one that I'm like, I'm not sure if I've convinced myself of this, or if I can convince you of this, but it's something that I thought I'm like, yeah, why is that still a thing? we've had slicer softwares that can talk to 3D printers since like one of the first MakerBots. So like decade plus, okay? And we and it does it through wire. It can do it through Wi-Fi, Bluetooth, whatever you want, where you can just send files from your computer to your 3D printer on the other side of your office, whatever. Why do 3D printers still have screens? Do you
I
get what I mean?
think so. I think part of it, let me take a stab. Part of it is Bamboo got pushback with their proprietary slicer software, where you have
Mhm,
to kind of put it through the Bamboo slicer to be able to communicate, and it's
mhm.
closed source. It's not there, and it's
Yep.
cloud-based. And companies and defense manufacturers and people that need to keep their things proprietary go, "Hang on a minute. I'm actually not that interested in sharing what I have to offer over the
Mm,
cloud." And
yeah.
so I think a lot of it has to do with the open source nature of the Ender 3 and the way that people transferred files previously, because otherwise you'd have to build out that whole protocol
Mhm.
and it would be observable by others because it's over Wi-Fi. And
Yeah.
also, if anything about it broke, you wouldn't be able to tune it. But that's the best I can come up with. I'm
Yeah.
not
Like you like we've had so many different softwares where you can just like link it up with the IP of the machine. I know technically they'd be saving a bit of money with the screen and the knob and the wiring and all that. Pretty minor. It's not a non-zero, but it's pretty close. But I'm like, if I'm already like making my model on my computer, slicing it on my computer, or I'm looking for models on my computer, there are programs where I can preheat my nozzle, preheat my bed, set the all the parameters, and send it. Like, I'll like why not just get rid of the screen? Just have this is with the mindset that it does work. That it's not like a printer where it goes, it's not working today. Sorry. I'm like, I get how it is advantageous to have like a thumb drive and like a little screen just to click it. I get that. This is with the mindset that everything works beautifully. But I'm surprised that we haven't seen a printer that's just a 3D printer with no physical UI that you just kind of do all the slicing and just go and send it and it works. Because I feel like all the bits and pieces still there. Like the only downside or the only upside that I can really see, it's a more simple 3D printer that costs slightly less. That's about it. But I'm like, but I'm surprised that nobody on this side of chasing the bottom end. I want to make the cheapest 3D printer possible. Hasn't thought of removing that.
it's interesting.
Yeah,
It's interesting. I
I don't
wonder
know.
if yeah. Yeah. I wonder if it's just one of those in some ways similar to the nozzle. You're just used to having a screen, and so not having one would be like, "Whoa, whoa." I guess there's also a bit of, there's some fine tuning you can do by pressing the buttons and knobs and screens as it
Mhm.
prints, which you could technically do on your computer, but when you're printing, you don't always wanna have to have your computer next to your 3D printer. Sometimes, right, you're just coming up to check it for a second, and you're not even your phone isn't up, your computer or your I guess you could put it on your phone as well. You could just have the adjustment settings in your phone. I don't
Yeah,
know.
yeah.
I'm not sure.
The only reason I thought about this because we were printing an order and shipping it, and I have a little thermal shipping label 3D printer, sorry, 2D paper printer, and it doesn't have any buttons on it. It just has an on or off, and
Yeah.
you open up, slide it in, and I'm like, all of the software, all the drivers that I'm using is on my computer. I just kind of say print, and it goes bing, and it prints it.
Yeah.
It's not like a home printer that has a copier and a scanner and a this and that and all the bits and bobs that actually does need some UI. It's just you click a button and it goes. Hmm, that's a little funky. I don't know. I can't think of too many reasons why you would take it away or why you would keep it. I'm kind of in the dead man's land with that.
I mean, I guess what if we apply that to other appliance thinking? Now that we're right, so what if why does your microwave have buttons? Why not just click something on your phone? Why does your car stereo
Well,
have
because
buttons?
I'm doing nothing with my microwave that used a 3D that used a computer from the first bit, but I am using it with my 3D printer.
Okay. Valid point. Valid point.
Yeah, again, I don't know if I'm just convincing myself of something, or if
Huh.
I'm in the same way that we have appliances that we added technology to it that's completely unnecessary. You can go on Amazon and find a crock pot that has built-in Alexa. So you can be at your office and say, "Oh, Alexa, start the crock pot for 4 hours," and then your crock pot at home turns on. That's I kind of hate it. I kind of hate that product. It's unnecessary. It's an unnecessary added when it doesn't need to be there.
Huh.
Anyway,
Good point.
we've only got 4 minutes left. Anyway,
Yes.
um, hobby CNCs that, but with soundproofing. Large industrial CNC machines, they're going to be in areas in machine shops where loud noises are pretty common. That's why you find a lot of manufacturing areas next to airports, because there's loud noises there anyway. That's why there's not a lot of residential areas next, or there shouldn't be, next to airports. That works. Hobby CNCs, the small desktop CNCs, they're almost always going to be in a house, in a residential area, in a place with neighbors. They are still loud, loud, loud things. And it's similar with a resin printer. Like, I've seen people where they build these huge superstructures where they're filled with super thick, deadening foam. It doesn't completely make it mute, but it helps pretty significantly. And I'm like, what? I don't understand why they aren't that little bit larger, or just kind of have some built-in soundproofing mechanisms in it. They're
I
always
suspect
bare bones.
I suspect it has to do a lot with price, that
I bet. I
the
bet.
at-home consumer is very price sensitive,
Yeah,
and
I bet.
so you don't wanna tack on an extra $500 to a machine that people are on, like.
Maybe that is a good thing where you should build a superstructure yourself.
Yeah, and honestly, you should build a superstructure yourself, not only for the sound deadening, but for the dust.
Yeah.
So, we're talking about here at the local community shop class, we were talking about putting a CNC in and where would we put it, and the 2 major considerations I had were soundproofing and dust.
Mhm.
And you can kind of do those things together. So you can build a structure around it that's got some sound dampening materials around it. You can encase them so that fire hazard as well. PC Van Fleet says, yeah, that's also true. It's now that you've got materials around your CNC that could heat up, right?
Mhm.
Yep, there's a bit more of a
We
fire hazard
were
there. But I would say some of those like fire resistant blankets inside of a wooden structure would work really, really well.
Yeah, yeah. We were asked, about a year ago, to use and review a desktop 3D a desktop CNC machine that mainly cut aluminum. And I used it for a fair few weeks and came to the conclusion that this isn't a good product, and I would feel bad making a video about it and trying to convince our audience, you guys, to buy this. I won't say the brand name. Um, it was a much bigger name in a very different community that neither Josh or I are a part of, that brought into the more general 3D print, general CNC world. Very well made, but with several flaws that just made it damn near unusable. And one of them was that the lid that you would remove was held on with magnets. So every single time that I would rough something out of aluminum, as soon as you would tunk, pop off the lid, little shards of aluminum cuttings would go everywhere, absolutely everywhere. And so you'd just be walking, and I'm like, "Ow, the heel of my foot all of a sudden feels like there's a nail in it." Like, I'm like, "Ah!" Peeling it out. It was horrible. Yeah. So but it ended up, cables got in weird places, and we had to ship it back. So we just said, "Hey, we can't do this out of good, uh, what's the phrase? Good faith of heart."
Thanks for shipping us the
Um,
CNC. We tested it, not for us. Appreciate the offer.
yeah, not for us, definitely not for you guys. And we don't really get asked to do review units too much. We
No.
don't like that type of content. It's not very interesting to us. There's a billion other people. The whole purpose of those review units is just advertising from
Yeah.
that product, and it's like, no. We're
Yeah.
already a business. Technically, every bit of content that we put out is advertising, you could argue. As much as I don't like it, I just want to make cool. I just want to make cool stuff. And having an ad inside an ad is just kind of ugly and disgusting. So I'm like, nah.
Yeah, we try to
All
avoid
right.
it unless it's something truly rad and awesome.
Yeah, yeah. All right. Last thing. I want a CAD mouse that isn't $200.
Oh, one of those like joystick.
I've heard nothing but
Oh.
amazing things. I can't remember the brand that does a little CAD mouse, and people like you can zoom, orbit, and pan with flick of a wrist. That like has a little bit of a learning curve. You can learn that learning curve over the course of like 4 hours, and it makes life so much better. It's got custom buttons on top and this and that. And I'm like, that looks amazing. How much is it? Like, well, the full size one is $500. The cheap one is $200.
So PC Van Vliet says Connexion. I don't know if that's...
Connexion. That might. It's got like I think a blue ring on top. It's like silver and black. Awesome. Super, super, super awesome. I want to see like everything that we try and do, that we try and teach you guys, is all with materials or tools that are either free or very, very inexpensive to kind of get you into the rhythm. Like, there's no point in us making a course for the mass public about a CNC machine that costs $20,000. Like, we're just not the guys to do it. And yeah, so the mouse that I use is like a $25 Microsoft mouse. It's dead simple, and it works for me, and it's all I really need. And I'm sure they're wonderful, but for the life of me, I cannot in good faith say, oh, we highly recommend this mouse. It's $200. It's like, oh my God, that's insane. So I want one of those that isn't going to break the bank for most people, that hobbyists can use. PC Van Fleet says there are some 3D printed versions. That's beautiful. I want a nice, neat product that's always going to work.
Yeah, I will say, so Bamboo has a really awesome project. So they have a mouse kit with the 3D printed designs for that mouse kit already, and you get it and you have to kind of assemble your mouse that you just 3D printed. And I think that style of, here's your design that's a CAD model that's pre-made and ready to roll, but also a mouse that we know works, and here, put them together and then customize it if you want to make a little, size it for your hand or whatever, is kind of an interesting hybrid between the two. But yeah, I've never seen those for under about $150.
Yeah.
Pretty pricey.
That's a lot.
Yeah.
Anyway.
Marion says, buy one, cry once. That's the key.
Yeah.
And on that note,
Josh,
by next week at this time, Jake, we should have a book out. Who knows if it will be approved by the Amazon gods, but hopefully it will. And on that note, this has been the CADclass podcast. Once again, I'm Josh.
I'm Jake.
And we will see you next week.
See you guys.